T connection, and the goal is to connect the three with the same air injection.
Okay.
So this is why.
What do we can separate which one is carbon dioxide and which
Normally, it's not always respected,
yeah,
but normally in red it's the carbonic gas.
yeah,
Okay.
Always. And after in blue or the colors is air.
yeah.
Okay.
And these valves are just for air, and here it's for the
carbon.
CO2. Yeah.
Okay.
And after here you have some valves to regulate the flow rates for carbonic gas and air. And here we will maybe connect the T here. Yeah, I think it's better.
What is our last step now? What we're going to do?
Just install the air and remove the bubbles.
Remove the bubbles.
Yeah, here.
Why we want to do that?
And homogenize the system.
Homogenize the system.
Okay. So,
But when we put the air, it automatically produce some bubble.
what?
When we put the air, it automatically produce some bubble.
Yeah, you will see in
But
few
if
minutes.
the pressure, if the system makes pressure, air is coming, then
Yeah. Okay, so. Ouais, vas-y, pas de souci.
Is it possible to see how much quantity of
No.
carbon dioxide we have supplied?
No,
No,
not
because
with
we have
this.
regulation,
Because
but we don't know how much pressure carbon dioxide we
yeah,
have.
I agree, but normally to do this you need a flow meter.
Flow meter. Oh yeah.
Yeah, but we don't have it here. Okay. So
It means if there is too much carbon dioxide, it would not be problem.
what? Sorry?
If there is excess carbon dioxide, it would not be problem for the photobioreactor.
Yeah, but it will be regulated
Oh,
by
by
the
PS.
probe
Oh.
and the electro valve, because we will put here
In
the
this
value.
Okay.
It will be you will have it in this your documents. It's 7.5.
Yeah.
So you will put 7.5,
Yeah,
and
okay.
when you will be above 7.5, you will have an opening of the electro valve.
Yeah, okay.
Will inject carbonic gas inside,
Yeah, okay.
and after, just when we will at 7.4, for example, it will stop.
Yeah. See.
Yeah.
Yeah.
And here you have to open this slowly,
Yeah.
because you will not have to inject too much carbonic
Yeah.
gas.
It means physically we can fill by this bulb, but chemically we can regulate by using probe. Is it?
Yeah.
Yeah, okay.
So
Prediction. Hypothetical assumption.
And why did you separate the carbon and air?
here,
Yeah.
why or where?
Why? Yes. Why did you
Connect
decide to connect it
Yeah,
T-bolt
because-
and-
because you need to homogenize the system,
Mhm.
so you will have a higher flow of carbonic gas,
Okay.
air, sorry.
Okay. Yes.
And you will have to put both at the same time. For example, into the middle one.
Mm-hmm.
And here I made just
One deviation.
both
Uh-huh.
a deviation for both,
Okay.
just with air
All right.
here.
Okay. Okay.
So here you will have air, and here you have some valve, because it will be complicated to equilibrate the flow.
Mm-hmm.
This is why it's recommended to have this.
Okay.
And after we
This
will
is same here, but divided by 2 or what?
yeah,
Yes,
yes,
for,
the same. Yeah.
Yes.
The same here, here, and here is for.
This is carbon. This is separate because this is carbonic with the air. That's why it is supplied by like this. Yes.
Yeah,
Carbon dioxide with air, but this is only air.
Mhm.
That's why it is separated into two.
yeah,
Yes.
exactly.
Exactly.
Pilot
So now-
connection.
Now for this part, we're just going to add air, not carbon dioxide.
Yeah,
Yes, sure.
normally,
Right.
but I'm thinking about something. This
Yeah.
is the fact that we will use this.
Yeah,
It's
okay.
an event filter
Mhm.
Yeah, okay.
for air, and normally I will plug it here, so maybe it will be more interesting to make the deviation here
Here,
to
here.
have the filter.
Yes,
Otherwise, I will have to use more filters.
exactly.
So I will do that.
We don't supply carbon dioxide inside the photobioreactor. It's
Not
if you
carbon
put it-
dioxide now.
Yeah, it's both. Both. In this
Both?
case, it will be both, but it's not a problem because the flow for the carbon dioxide will be divided by 3,
Mhm.
but it will be the same amount.
Yeah,
Okay.
Okay. So I plug it here. Okay. So here. The thing is that is autoclaved. So I will show you how to use fire. To be
It's there.
Yes.
Yeah.
Very good.
Now we have to adjust by 4.
And after pH 4. So pH,
Mhm.
enter. 1 point. It's okay.
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 4-1.
Okay. And
What
now
did you do
here,
exactly?
I just set up the pH calibration.
Point.
Just to push calibrate,
Okay.
and after push pH,
Okay.
enter. After 1 point, enter, and that's it.
Okay.
And you have the real pH and the calibration point.
Okay.
So
Which
you
one
have
is
to
real
wait.
and which one is calibrated?
This one
So
is a real pH, and now it's a value that you have to reach.
adjustment?
Yeah,
1.01.
it's an automatically
What is it
adjusting.
showing? 3.9?
Yeah, it's a real value of the probe,
Oh, yeah.
and this is the value of the solution.
Why
It's
should
an
we-
automatically detection.
Why should we need this? Like, why do we calibrate it?
Why? Because the pH of your PBR, your culture, will be monitored by this probe. For example, for freshwater green algae, you have to be between 7 or 7.5 for pH. And during the photosynthesis process, you have the production of O2, the oxygen.
Yeah, oxygen.
So the oxygen will basify the solution. So you will go to, for example, 10 of pH if you don't have a regulation. And the O2 will be toxic, and the increasing of pH will be toxic for the cells in the culture. So this is why you have to regulate by the pH, and also you have to bring carbon source for your culture.
Yes.
And it will be the possibility to combine both.
No, not my question. My question is why we need additional calibration to like 4.9?
Oh, because it can change.
Mhm.
Okay.
Okay, it can change, and you have to verify everything before you launch the culture.
Oh,
Always. Because, for example, if your probe is have a problem, if it has a problem, you don't calibrate, for example, for a pH of 4, you have 7. So imagine that when you will reach with a real 7, you will be at 10, for example.
This means first one is Pro and second one is Solution. Yeah.
What? Which one? Oh, it's good.
Is this one Pro and
Yeah.
this one is Solution or what?
Yeah, this one is a real value there.
Yes, because we have two values.
And
that's
here
why-
it's the standard value.
Oh, yes.
So we have to reach this value.
Yeah.
So for example, for me,
But it is fluctuating.
it's okay.
Yes?
So now, we have a bug here. Yeah, here you have the same. So it's
Yeah.
okay. So now we can escape. Just push the both
Okay.
at the same time. Just verify.
You had to reach the same.
Normally it should be, but we have a little decay. But no, you just have to wait. But I think it's good because it's not a bigger difference.
Yeah.
Yes.
Okay, so now it's good. Rinse again, and after just put it here inside the culture, and after we're not able to remove it again.
Okay.
We don't remove it anymore, yes?
Yes.
Because if you change the pH,
No, because now the goal is to sterilize the
closed.
system. Yeah.
yes.
Now it's fully closed. Okay. So it's good. So what time is it?
Right
Ah,
now.
yes. So for me, so it's 10 minutes left before after we put the solution. So we will let it around 20 minutes more
Okay.
with a little air injection.
Yeah, okay.
When we inject, when we put microalgae in this,
After 40 minutes.
After rinsing, yeah. Because if you put
Did you grow
microalgae,
the?
look at the pH, you are at 3, and
Nice.
for microalgae it's too low. So you die instantly.
and we have to filtrate this also. In time, we have to filtrate. Yes.
No,
There's no filtration.
no filtration. You just have to discard this
Yes.
and replace it by just distilled and autoclaved water
Yes.
twice.
So what about the viscosity that it will change after microalgae we produce something? The
Yeah,
viscosity will change.
Yeah,
Maybe it will.
it will change here, but
So-
you will monitor it with the gas flow.
Okay.
Just that. This is why we will plug the free air connections.
So
Yeah. Do you have a question? The arrow for the flow direction. So we will
So which
inject
way we
the
put
air.
it?
So you have to put it in this direction.
okay.
And after, do something like this. And another part like this here. Sorry, bro.
No, we're-
Okay.
Oh, okay.
You see? Is it
Yeah, okay.
for you?
Now it is blocked. It means it will not pass.
Yeah. Exactly. And here I will do the same.
So one of them is inlet and the other one is outlet. Air.
No.
So-
just the inlet. Outlet is
So why we have two? Why we have two of this?
yeah, because for this
Here inside.
you
Yeah.
have a convection movement.
Oh yeah,
inside the
yeah.
culture.
Yeah, okay, okay,
For
okay.
mixing, you know.
Yeah.
Yes. You have magnet, but beside that is
Yes.
you have air supply, it means it will help to mix well. Hydrodynamics.
Yes.
Yeah, that's
I
it.
don't know.
Exactly.
So one is for air and one is for carbon dioxide, and we will mix it inside.
Okay.
Yeah. Just filter out, and this is for carbon dioxide.
Yes, reality exists.
Normally.
Okay.
Okay, so
Now it will be
I
ready.
just make a verification. It's not tight enough here because you will have a leak.
Oh, hi.
Masaya, you can ask if you have some questions.
Yes. So my,
Because if you want to participate or
Yeah.
something like that, don't
You're
hesitate.
for this course and you?
No. At the same time, it's here.
Oh.
Yeah.
But I just already here, and
Oh, okay.
I need to know where I can.
Yes,
how
yes.
to prepare.
Yeah, yeah, definitely.
Good luck.
Yes.
We are also
Yes.
doing like that.
So have you- Yes.
Okay, so let's go. So we want to try to fill the system.
Yes,
Yeah.
definitely, but
We will use just this. It's a verification.
Yes.
Just to be
for
sure
just
that
need to
it's not
for
leaking.
this one. Yeah.
Yeah.
Hey, what are they? Dude. He's pioneer. Yeah. Don't we have to pour it a bit slower, or it's okay?
What?
Don't we have to pour it a bit slower, or it's okay?
Yeah, like this is
It's okay?
perfect, yeah.
This is just water. We want to clean this one. Yes.
No,
Yeah,
we want to
after you, for the moment, we just want to check
Yes. Okay.
if they are leaking.
Yes,
So just check during the refilling.
But the amount of nutrient we have to calculate, or we can supply directly to the ammonia.
Oh, you have a leak, for example, here. And here
Yeah.
too.
There.
For the moment, what
Oh,
can
okay. This is not a good place. It's my fault.
for what purpose?
I just want that.
Don't.
Where is it? It's not a big deal, but here it's because here I will have a big leak.
Better to put here
Yeah,
because
because
there is already water.
here
it
it's
may flow like this.
yeah, here it's
There is a lot of water.
too low.
Yeah.
So I will use it.
Yeah.
Can you
Yeah,
unplug
yeah.
this?
Yes, yes, yes.
No, you just need to push this ring, the gray ring.
Oh, yeah.
Yeah. No. No. Not this. Not this.
that one.
Experimentation.
This. You see the gray ring?
Just pushing.
You have to push it, and yeah, that's it. Yeah, perfect. Thank you.
What was
Okay.
the main problem? It wasn't fixed.
Just
No, it was the wrong place for this. It was too
one
Okay.
one for removal of
because
nutrients
this
area
is
and
for
The outlet.
the output here.
and
Oh, yeah.
where will be our
So why
another way.
the output is so higher? Why the output is on the higher
This?
part? Yes.
this
Just
is
to have the good volume, just 1 liter, because 1 liter is just right here, and this here. Because you have all.
I think you have to clean the area first.
Yes, we have
So
to.
I will keep it here.
How can we access the paper and
So that's it.
Should I have to put all those?
No, that's it for the
Yeah.
moment. We will complete just after, because we will have to put some air
Yes, okay.
just to
Okay,
homogenize
yeah.
during the sterilization. So we will do it now. Yes, thank you.
Okay, we'll need more.
Still
do
need,
you do our organic what today?
Yeah,
but the,
At this moment?
yeah,
Oh, did you do?
yeah, because we.
there is
have
still
to
problem.
Let we are open to do it.
Maybe this is not well fixed because.
No, I think
Leaking.
this, yeah. Thank you. Oh, I have a leak.
Nobody is expert in that.
There is a leak here too.
We are learning. No? Yeah, no,
Okay, shit. So, unfortunately, we'll have to
Yes. Yes, sir.
put it back in the bottle.
Okay.
Yeah. I will change the.
Yeah, okay. It will be
Okay.
practice again, you know?
Okay. So maybe we can put it there and add a connection. No, you can let it.
More culture.
Yeah. Don't worry, I will take it after. No, it's this pipe.
Connector, we need connector.
Pipe.
It will act as connector, it will be okay.
Yes, this one is perfect.
Okay. For what purpose it
So
will?
you have to connect it just for the distribution of the salts.
Salts.
Yeah, the medium culture.
Okay.
Here, so you have a peristaltic pump. And
This is
after,
pump?
yeah, this is a pump, a
Yeah, okay.
peristaltic pump. We will plug this,
Okay.
Mm-hmm.
and after plug the pipe on it. And here, in this side, you will have the bottle with the medium culture.
Only culture,
medium
yeah.
culture? Yeah, okay.
Exactly.
Yeah. And could you tell me for what purpose we are putting those stuff?
Here,
Storage video.
Oh, don't worry. Don't
Just-
worry.
just-
anybody have an answer for this?
Yeah, we will answer.
You have
For
a question?
what is the purpose of these tubes?
Can we?
Like one maybe for
We
inlet,
have what, sorry?
one maybe for outlet, but I found three. That's why I'm confused. Which is inlet, which is outlet.
Ah, yeah, of course.
Oh,
So
this
for removing the
this
culture,
one for inlet, yeah.
What?
Yes.
for removing the whole culture.
Yes, you can use
This
one.
is this is
but
inlet, yes.
Yeah,
Because we supply media from here.
Yes.
That's why this is inlet, and
Yes.
red will be outlet. This one at last will be for harvesting section.
no,
No,
no.
we will.
We will change
It's-
later.
You just
Don't worry.
right here. So outlet is right
Oh,
here.
outlet.
So you will plug a pipe here
Oh, yeah, okay.
just to
That way.
collect the
Okay.
culture.
Yeah.
And you
okay.
see-
But for rest of the for supply carbon dioxide one for, and other for one for supply of carbon dioxide gas because we have to supply,
Yes.
and other for what?
Other for air and CO2.
Oh,
Yes.
Yeah.
For what?
One of them is for air and the other is for CO2.
Yeah. But for example, in the middle, you can have both injections of air plus CO2.
Yes. Yes.
And just here and here, just to you have
And why you don't have flow meter?
because it's not a perfect system.
Okay, just
But
for training.
You have some valves here to regulate the rate, the flow rate. And here you have a little view of the PBR. So here you will have a convection thanks to the air injections.
Is this one?
For what?
I don't understand what is-
Yes, for the dosing pump. Here, the peristaltic
Oh,
pump.
yeah. This is a
Is
nutrient pump, yes. One, and other will be gas outlet.
Yeah,
Is this one?
yeah. You can use
Oh,
this
yeah.
one.
This one.
Or another one. But where is it? It's here. Here, it's for the collection,
Okay.
the sampling.
And also, so what is our flow rate now? It's not important what is our flow rate.
The flow rate for the distribution of
Yes.
the medium culture?
Yes, yes.
Yes, it's important, but it will be calibrated by the
Oh, sensor.
peristaltic pump.
Mm. Before that,
But
we have to
the flow
calculate
rate
as
for
well.
the air is not really important in
Oh,
this
okay.
system.
Oh, yeah,
In
okay.
this system.
Yes, in this system.
And
Because we will have free entry for the air
okay.
and the specific one for the carbonic gas. This is the most important. And if you have sedimentation, you have the magnetic bar.
Okay.
So that's it. And what do you think is getting here?
For lubrication,
Here?
lubrication,
No.
or
Yes, I
Do
will.
you have any idea?
to pour
You
microalgae.
can help you with this.
Yeah.
Maybe.
I think this is gas out.
One is gas out,
What did you think?
Wash the
Tiffany?
system.
pH probe?
Yeah.
pH probe. Because you have to measure the pH inside
Because you have to monitor the pH.
Ah, the
regulate
sensor.
The CO2.
sensor, yeah.
Alright.
Yeah. And here you have an electro valve. Just it's hot. Oh, okay, it's normal. It's because the probe is disconnected.
Yeah, okay. You said this is continuous, yes? So that we have to have a measure of flow rate.
Yeah,
before
but we will do it after.
Like,
We will
okay,
calibrate.
okay,
after.
okay, sure.
So first, we have just to plug the connections here before to refill it because it will leak, obviously. And after we will calibrate just the pH.
pH.
probe.
Alright.
So here, sorry, I have some material.
7.5 pH.
This is media already prepared?
No, it's just water for the moment.
Yeah,
That
yeah, okay.
will become media for this one. And this one is just autoclaved and distilled water, just to rinse after the peroxyacidic acid.
Okay.
Here it's another bottle, just to avoid the foaming formation from the algae, because sometimes you have a lot of foam and this
Here?
can be stuck and the air cannot escape. So
Okay.
you will have a overpressure just here, and you will have leaks or explosion of the system. So it's a security.
Alright.
So what will be inside it? Or nothing?
Just foam, it's a foam formation.
Yeah.
Just that. And here you have some pipes,
Okay.
and here, for example, you will plug it there.
Yeah. Okay.
It's a quick release. For example, this you just have to push, and after you have to push this ring to put it up.
Alright.
Just that. So we will need three like this. So here we have a specific move.
Yeah.
It's a security.
Oh, just like putting this way, is it easy to remove foam? Automatically it will remove foam.
Yeah.
If you put like this.
Yeah, because sometimes if you have a lot of bubbles
Yes.
inside your cultures,
Yes.
and if your culture is old,
Yes.
you can have foaming formation due to the polysaccharides,
Oh, yeah.
etc.
Yes. Okay.
And sometimes if you plug directly something like this,
Yes. Okay.
an event, just to push out the air,
Oh yeah.
the excess, because you always need this an event.
Oh yeah. Oh, this is filter.
Yes, this is like a filter.
Oh yeah. Okay.
Yeah,
Excuse me. What does this mean?
this
Yes.
sampling.
Sample to take out sample.
Yeah, every day you will sample the culture to monitor the growth of the microalgae. So for here, you need just this pipe to
Okay.
remove the foaming formations, because if you have a filter and you have foam on the filter, because it's a 0.2 micrometers pores. Yeah.
Porosity of this filter.
Yeah,
0.2.
0.2 micrometers.
Yeah. Okay.
So no bacteria can pass through it,
Definitely.
and no foam either. So So you can stuck the filter and the air will not escape anymore. So you will have an overpressure inside the PBR and you will have a leak. For example, a connector like this can disconnect and you will lose everything. This is why it's a security for the flow.
And now what should we do?
We will
acid.
get the
What's the point of adding nitric acid?
point.
Yes, the point to add this.
Silence.
Sterilizing.
In the
Just
PBR,
this,
you say?
yes, yes.
Ah yes, it's just to sterilize. Just that.
Okay,
And,
you concentrated, yes?
Yes, yeah, it's very concentrated. And now, I put this here. If you want, you can take just one tube.
Okay.
For what purpose?
No, cadeau. It's gift.
It's for the solution for calibration. The probe calibration, if you want to take one. It's one solution for calibration on it. And we will use it to calibrate.
Yeah, our day-night cycle for this 24 hour.
What?
Day-night cycle.
Daylight? No.
It's me. It's 24 hour continuous cycle. Yes.
So we have to remove this
Yes.
and we just measure how much
How much we
In
will
200?
obtain in milliliters in 1 minute.
okay.
Yes, it's
Flow pipe out. Just pipe out. It is not done at 205 initial. 0.205.
You have to plug this
Yes.
back.
Yeah. Okay.
On here?
Yes.
In one. But did you put the chronometer?
No.
So you have to monitor the time.
Yes, or just
Yes. I'm
stopwatch.
looking.
No, stopwatch. Okay.
Stopwatch.
Okay. Just time will be good. Okay.
The time with yours.
Yes. Look at here. How much should I have to
What
put?
happened?
1 ml?
Did you put run?
Yes,
1
yes,
ml
yes.
should I have to put? How much should I have to allow
It's
to
not working.
flow? Yeah.
We will see, depending on
Oh
the time.
yeah, it is. It is in continuous mode
Yeah.
and it's
Maybe we
flowing.
will restart it because it will be too low, I think. We'll put the maximum first.
5.
Well,
20.5.
What's happened?
Push it.
I just press the run button and it's showing.
20.5. Still same.
You have to avoid the ball, so
1, 2, 3. Maybe for the speed. Yes. Just starting from 30. When increasing the maximum, we will starting this. Yes, sir.
that's weird.
Not now.
10.0.
No, just 2, 3. Yes.
Oh, you success. You success one.
Yes.
10. 10. Now it is okay. Oh, up to how much quantity should I have to allow it to like a flow? This means 1 ml. Yes, I mean to say up to how much quantity should I have to allow this flow meter to flow its liquid? Maybe.
How much quantity?
Yes, like 1 ml, 2 ml, like up to how much time should I have to allow it?
1 minute?
Oh, 1 minute. Yeah, okay.
Maybe you
1
can
minute.
do less, but it depends on the flow rate.
Yeah, okay. Normally
If
we
you have a high flow rate, you can decrease the time.
yeah. It means normally 1 minute.
What?
Normally 1 minute.
Yeah, often 1 minute, but you can do it more. Because, for example, if we decrease at a minimum, we will wait maybe 1 hour, 2 hours
Oh.
to have a
1 minute 04.
Start this.
1.04. Okay. Screenshot time. 1.04. Talk me. 1.04 time. This time.
12. Less than
And quantity.
Yes, it's 12.
Quantity is how much?
You can separate.
Just allow to do.
12. Someone writing?
Yeah. Talk me 12 ml.
Just 5 seconds.
12 ml.
Yes.
I never see this kind of
It will be okay for you to come here.
It means if you increase the intensity of
We have the folder here on that copy.
How much did you get?
Maybe I sent it before. Yeah. See this. Is it visible?
yeah, okay.
We should not use the custom.
Yeah, I heard about that. Yeah. So maybe I will.
Oh, so many photobioreactor.
Which lens do you want to calculate?
From here to here. It's okay.
So it was like that. So now what?
Oh,
Because to use it, there are different flows. For example, if you want the diameter of the scan, you will use this torch. But if you need to measure